Hello, Professor. Good evening.
Hello, good afternoon. Okay, so good afternoon again. It's 3 minutes past 4, and so we can start. The usual question: can you see me and see the presentation on my screen?
Yes, Professor, we
Yes,
can
we
see
can.
your presentation.
Thank you. So this is lecture number 18, and I've uploaded the last lectures dedicated to adhesive, and the last, this is not the very last presentation about coatings, which will be the last part of our program. Next lectures, only three left. This Friday and next week, Wednesday and Friday again. And so three lectures, four with this one. We have to finish everything about the program. The presentation, the program. Okay, let me show. This is the program. It is complete, and for today there are two presentations. One from Anna and Tito. Can you confirm you are here?
Yes, Professor.
Okay, thank you.
But Professor, I don't know, my other partner cannot join your class. She has problem with the link. I shared her the link, but she cannot enter.
I don't know what to do.
Her name is Anna. I've already shared her the link, but I also don't know the problem. Let me try again, Professor.
Can I try? If you send to me her address, I can try to invite directly.
Okay, 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 Professor. Just
Okay.
a moment.
And the second presentation is from Wanda and Ralph. Sorry. Can you confirm?
Yes, sir. We are
Yes.
here.
Yes, sir, we are here.
Thank you very much. So this is all for the next Friday. There are four presentations, sorry, and again for each of the following days of the next week. So that's all for the presentations. For the exam, nothing to say. Just could add that.
Professor, I have shared the mail address of my other other group mate.
So it's I think here. Yes, but Anna, I think, is already with us or not.
Her name is Anna and Adrover. I think
Yes.
she's not here. She's not in our class.
Okay, let me try to invite. Hmm. Hmm. Oh, I have tried it by email. Let I sent an email to Anna, and then let's see if it's possible for her to. Okay, I think she's here.
Yes. Hi. Thanks.
Yes, Vanessa.
So good. Welcome also to you. I was telling something about the exam. One student asked me to repeat the first part on Friday, the 4th of June. So I've already answered him that it's possible. So if any other student would like to repeat the first or the second part, remember that you have many options in this list, or you can also contact me if you need other dates for any reason you may have. Okay, so what else? Okay, today it will be a short lecture for my side because there are two presentations, and so I would like just to repeat something about the adhesives. In particular, I would like to finish with the terminology session, and then go on with the presentations of the students. That's all, I think, and now I could close this presentation and go on with the other. I would like just to before the terminology section, I would like just to repeat some concepts that we have considered during the last lectures. The first refer to creep. So in this slide, I have tried to represent the two pieces of wood, and in the middle, the adhesive represented by the raising chains. Remember that the creep is the movement or the sliding of the polymeric chain which make up the adhesive. So this problem can appear only with thermoplastic adhesives. For example, with PVA, polyvinyl acetate adhesives. And the reason the creep, the sliding, the movement is caused by a constant load applied to the joint, and this constant load causes, as you see here, the movement of the chains until the joint is broken. So this can happen, as I already said, only with thermoplastic material, thermoplastic adhesives in this case, because if you remember, there is no chemical bonds between the polymeric molecules, and so this phenomenon can take place. In the case of thermostatic adhesives, this creep cannot happen because, as we know very well, thermostatic adhesives are completely cross-linked. It means that the polymeric chains are bonded together by primary chemical bonds, and so this movement is not possible. A typical example of creep you have with your chewing gum. You know that you can stretch it and this behavior is due to the presence of linear molecules. Also, your chewing gum is made of polymers, linear polymers, and what you can do with it, it's simply because of the possible sliding of the big molecules which make up the chewing gum. Okay, this is something related with this idea of creep. Then we mentioned the dispersions or emulsions, which are special liquid systems. The adhesives we have analyzed are made of water, the dispersing agent, and we said that there are many resin particles completely entangled. So the resin and water, they don't like each other. It's like water and oil that we know that we cannot mix them together. But we said that there are special substances called surfactant or emulsifiers. Having this special special form, the molecule is made of one head, which is a friend of water or water attracting head, and the tail, which is a friend of oil or friend of the resin in this case. And so when the surfactants are mixed in this system, where there is resin, there is water, the tail is directed toward the resin, while the head is directed toward water. And so with this emulsifiers, or with these surfactants, it's possible to stabilize the resin particles inside water. So finally, we can imagine that our adhesive is made of many of these resin particles surrounded by the surfactants and inside the water medium. This special products, we said that they are not particularly special because there are many products we use also every day. Milk, for example, ice cream, also the hand cream, mayonnaise, so butter, and many others are made with this system where there are surfactants acting as a sort of bridge between the resin and the medium, which is in this case is water. This is important because, as we said last time, during the setting, during the hardening of the adhesive, water is released, of course, and the resin particles must open and merge together. And we said that there is a special temperature called the minimum film forming temperature, below which this resin remain entangled, remain closed without opening and without merging with the other particles of the adhesive. And this is a serious problem, especially for cold places. Um, if, the dispersion adhesives are used in cold, in cold environments, there is this risk of working below the minimum film forming temperature, and so the adhesive will not produce a proper film to allow the contact between the two elements that we want to bond together. So this temperature must be always considered in the case of dispersion adhesive. And if you remember, we mentioned also the name of this process, the name of the setting process of emulsion adhesive. We call it coalitions. Coalitions because the particles must merge together. Coalitions means the union of the particles. So this is the short story about dispersions and the reason to take care of the technical data sheets where the minimum film forming temperature is always declared and must be, of course, known and respected. We also mentioned the behavior, rheological behavior of the adhesives. In particular, we said that many of the liquids we know behave as Newtonian liquid. So it means that their viscosity is constant independently of the movement. If we mix them or with a low speed or with a high speed, the viscosity is always the same. The viscosity means the resistance of the adhesive to the movement applied. I think it's quite common to know that if you try to mix water, the effort you have to make is quite little. While if you try to mix the oil, the effort you must make is higher. The effort is related with the viscosity. So the viscosity of the oil is higher than the viscosity of water. And it is related to sort of friction among the molecules of the liquid. So in the case of water, the friction among the water molecule is quite low, and so you can mix them without making a big effort. When you mix the oil, the friction among the oil molecule is higher, and so the effort you must apply is of course higher. So this is the story of Newtonian liquids. The Newtonian liquids are those which viscosity is the same or does not vary with the shear rate, meaning with the movement of the liquid itself. But we said that there are other liquids with strange behavior. In particular, we mentioned the pseudoplastic behavior, and we said that these liquids show a decrease in viscosity with the shear rate. So this means that if we mix with a high speed, the viscosity becomes low. If we don't mix them, or we mix with a lower speed, the viscosity is high. So we must make a big effort if we mix them with a low speed, and the effort will be lower if we mix them with a high speed. These liquids are called pseudoplastic, and we said that for certain applications, for example, if we apply an adhesive or if we apply a coating in vertical, this will be a good property because while we apply, the viscosity is low, so we can easily apply the adhesive on a vertical surface. But when we have already applied it, the viscosity increases, and so the adhesives remain on the vertical surface without creating drops and falling down. So this is a good behavior for vertical applications or for applications on wood-based panels, preventing the absorption by the panel itself. So again, good application, for example, with the spray system. So with the spray system, the liquid is moved very fast, and so the viscosity is low. Very good for this kind of application. But when the adhesive reaches the panel, the viscosity increases, and this prevents the adhesive to disappear inside the panel. This is a typical, this pseudoplastic behavior is typical of the polyurethane dispersions, which are normally applied by spraying on MDF panels, and so this behavior is a good property for the reason I've already mentioned. There are some other liquids that just for your curiosity, we can simply mention the dilatant liquids. So they have a different behavior. So they have a low viscosity when they are mixed at low speeds, and they show a high viscosity when they are mixed with an high speed. There is a little video here telling you something more about Newtonian and non-Newtonian fluids. When it was possible to have the lecture inside the classroom, in some cases it was possible for me to do this experiment. You will see here in the classroom. Unfortunately, this is not possible.
Hello, and welcome to another Science Man digital lesson. Today, we're going to take on the interesting topic of Newtonian and non-Newtonian fluids. A classic Newtonian fluid is water. Water has a very predictable viscosity. It will always flow predictably, regardless regardless of the forces acting on it. Newtonian fluids also have predictable viscosity changes in response to temperature and pressure changes. To investigate the properties of Newtonian fluids experimentally, let's start with some warm honey. As you can see here, warm honey flows easily, and it will easily flow around objects, such as this ruler. Placing a force on the honey has no effect on its viscosity. Even if we place a large force on it with a hammer, the honey predictably flows around the hammer. If we try the same thing with cold honey, we see, as you would expect, the honey is more viscous. That is, it flows slower. But when we test it with the ruler, we see it behaves much like the warm honey. It's the same when using the hammer. Applying a force has no effect on the viscosity. Honey, whether it's warm or cold, is a good example of a Newtonian fluid. Let's try a different fluid. We'll perform the same test with cornstarch solution. When you pour this solution, it appears to behave much the same way as the honey. When you place a ruler into it slowly, the fluid flows around the ruler. However, when you attempt to force the ruler into the fluid instantly becomes more viscous. Hammering the fluid with even more force produces even more resistance to flow. Because a cornstarch solution's viscosity changes with an applied force, it is a non-Newtonian fluid. Unlike a Newtonian fluid, applying forces to this non-Newtonian fluid causes its particles to behave more like a solid. This makes the behavior of non-Newtonian fluids very strange. As you can see here, even though cornstarch solution flows when emptied from a bucket, you can't break its surface even when using a sledgehammer. You can even jump on and off a cornstarch solution. Just remember, don't stand on it, as you will eventually sink. So in summary, non-Newtonian fluids have unpredictable responses to applied forces. With applied forces, they become more viscous, such as cornstarch, or less viscous, like ketchup. What other fluids might you suspect to be non-Newtonian fluids? Try your own fluid experiments to find out. Thanks for viewing this Science Man digital lesson.
So the ketchup, sorry, the ketchup has this the red curve behavior. So is absolutely plastic. So if we apply the force, if we mix it, it becomes less viscous. The corn solution was a dilatant fluid following this green curve. So when we apply a force, and when we mix it, it becomes more viscous. The only application I know for dilatant fluids, in the case of gloves for the hands for workers. So if you move these gloves slowly, you can easily move your fingers inside the gloves. If you do, for example, if you work with a hammer and the hammer hits your fingers, the gloves partially prevent the impact because they became partially solid, and so they absorb the energy of the hammer. So there are some interesting applications of this non-Newtonian fluid, non-Newtonian liquid. So now we know something more about such interesting liquids. Of course, this is not a miracle. It's simply behavior that can be, of course, explained by the physics, and there are also some additives which can be added to coatings or to adhesives to improve their non-Newtonian behavior. As I said before, especially for vertical application or to avoid the absorption by the fluid, it's possible to add some special additives to modify the viscosity of the material depending on the force or the movement applied to the adhesive or to the coating. Okay, that was all for this part. Now I'd like to finish the part dedicated to the adhesive with the terminology section. Just to repeat some of the terms we have used during the last three lectures. Okay, we started with adhesion and cohesion. Remember, they are forces. Adhesion is the force acting between two different materials, and cohesion is the traction force acting inside each single material. Then we have analyzed the different bonding theories, the mechanical theories. Remember the feeling of the adhesive, of the porosities of the substrate, then becoming solid, and so preventing the two materials to be divided. Electrostatic, we said it's not so important for the furniture sector. It is related to this separation of the electrical charge, so that the creation of this dipole, positive charges on one side and negative charges on the other side, and so this can create an interaction, a prophetic interaction, and in principle an adhesion between two substances. Chemical absorption is the theory explaining adhesion with the formation of primary covalent bonds. It's a good theory. We said that it can explain adhesion only in some specific cases, only with chemical reacting adhesive, and with some particular substrate. So it's a good theory, but it can explain adhesion only in some particular cases. The diffusion is the mixing of the polymers of the two materials. Again, this theory can be applied only for plastics, only for. Sorry for this noise, but they are cleaning the windows of my office, so you can maybe listen some noise on the background. In any case, diffusion, like I was telling, that it can be the theory explaining adhesion for some particular materials, especially in the field of polymer and plastics. So they must dissolve and diffuse. The molecules must mix together and diffuse to create this mixing of polymer chains. The last one we said is the most important theory, especially in our sector, in the printing sector, but not only. And we said that this theory can also define as the contact theory because the theory explains adhesion as the result of many with a large number of contacts. Every contact creates a little attraction force, and so the explanation of a good adhesion is the formation of a large number of weak contacts. So the theory is based on the formation of these secondary forces. We mentioned the van der Waals forces, the acid-base forces, hydrogen bonds, which are all weak, but again, with a big number of weak forces, we can create a very big force. We also mentioned the difference between these two terms. Absorption is when something goes inside. Adsorption is when something goes on the surface of another material or of another substance. So abs means inside, ex means on the surface. Then we have considered the surface tension and the surface energy, which is something strongly related with wetting. So with the ability of the adhesive to wet, to be in contact with the surface of the substrate to which is applied. We said that the surface tension is the force acting on the surface of every liquid, and the surface energy on the other side is the excess of energy that every solid presents on its surface. So the little secret to have a good bond is that the surface energy must be higher than the surface tension of the liquid. So only in this case it's possible to for the adhesive to properly wet the surface of the substrate. Otherwise, maybe you have also examples in your daily life. If you try to wet a plastic surface with water, you cannot properly wet it because the surface energy of the plastics is normally very low, On the other side, the surface tension of water is quite high. So it's very difficult or impossible to wet a plastic surface with water. And you have an example also, for example, in your plastic bottles, you see that water is not able to wet the surface. Only some little drops are formed, and this justifies exactly what I said just now, that the attraction force of the water molecules is higher than the surface energy of the plastics of this bottle. In order to improve the surface energy, it's possible to use special devices called plasma or corona. They supply a high energy fluid to the surface, which is treated, and this high energy is able to change the chemical composition of the first layer of the material which is treated by such system. So normally improving a lot the surface energy of the material treated. Okay, wetting means the ability to wet the surface, and the wetting depends on the surface tension of the liquid and the surface energy of the material. Then what else? Okay, thermoplasting and thermosetting. It's also something fundamental. In the case of thermoplastic resins, we said that we have linear polymers forming the material, and I've said that you can imagine like a spaghetti dish with all these long linear molecules mixed together. The properties of thermoplastic adhesives, the good is that they are flexible. The bad is that they are not much resistant to heat, to solvents, and also to creep, because if we apply a force, the different molecular chains can flow each other, and so it's possible to see a deformation of a thermoplastic material when a force is applied on it. In the case of thermosetting, in this case, we don't have the spaghetti dish I mentioned before, but we can imagine it like a three-dimensional network. So all the chains are bonded together. So for thermosetting adhesives, we said the good is that they are more resistant to heat. They are more resistant to solvents and water. The bad is that they can be rigid, they can be stiff, they can be fragile, with all the possible consequences on their use. The creep, we have already said the meaning of this word is the sliding, is the movement of the molecules, of the linear molecules forming thermoplastic polymer, thermoplastic adhesives. Then we presented the different types of of adhesives. I don't want to go in detail with all these adhesives, but just repeating solvent-based contact adhesive. Normally, the solvent-based can be considered contact adhesives, and they are formed by rubbers, so very flexible resins that are mainly used in combination with upholstery furniture. Upholstery furniture means sofas, armchairs, and so on. So where we need very flexible adhesive to bond together the different material which constitutes their different parts. Then dispersion adhesives, we have already said what are dispersions, and we mentioned two types of dispersion adhesive, the vinyl adhesives and the polyurethane adhesive. In particular, remember the possibility for vinyl adhesives to be modified in order to be more resistant to heat and water. And there is this classification, an official classification with four classes from D1, which is the less resistant to water, humidity, and heat, up to the D4, which is the more resistant to heat, to water, and the D4 adhesives, for example, can be used for the production of window frames that are normally exposed outdoors. Other terms we mentioned become surfactants, or you can emulsifier. So they are these special molecules with these two parts. Coalitions is the setting, is the hardening process for dispersion adhesive. I've already said what is the meaning of coalitions. The minimum film-forming temperature, again, it's related with coalitions, with the merging of the resin particles. We said something about the density, but it's quite simple to know what is density. Is the ratio between the mass and the volume of every substance. Again, the viscosity with the story of Newtonian pseudoplastic or thixotropic and dilatant liquids. We don't need to repeat it. And finally, the hot melt adhesives. Remember that hot melt, the term hot could suggest their behavior. They are supplied as solids, granules, and for their use, they must be melted by heating them at very high temperatures, normally between 140 degrees Celsius up to 200 degrees Celsius. So they are applied when they are completely melted. And we said that their setting is due by their cooling, so they are applied hot, and after a few seconds they became solid because they cool down. The most important types of melt adhesive are the EVA, which are the most used by the furniture sector, then the polyolefins, and finally the polyurethane, hot melt polyurethane. And we said that this last class is different because during the application, the resins react with water, producing the cross-linking of the resin. So this EVA and polyolefins are thermoplastics. The polyurethane, hot melt polyurethane, are thermosettings. Initially, they are of course thermoplastic, but after the application, they are water promotes their cross-linking, so the resin molecules react each other, creating this cross-linked structure. So we said that this type of hot melt adhesives are suggested for environments like kitchens and bathrooms where we need a good resistance to water, good resistance to steam, good resistance to heat. So that's more or less all for the class of hot melt adhesives. And then we have finished last time with reaction adhesives. Reaction simply means thermosetting, so they set because of a chemical reaction involved, and the most important are the urea formaldehyde adhesive, which we already know very well because they are used in the production of the majority of wood-based panels. We have already studied in the second part of our program. We know what are the benefits and the disadvantages of such adhesives. In particular, the cost is very low. The properties are normally good. They are transparent. The mechanical properties of the final product are good for our sector. The most serious problem is the low resistance to water. We already know that water is able to create a sort of a degradation of the resin, which is known as hydrolysis. And this has two different drawbacks. The first is that we cannot use urea formaldehyde adhesive for humid places or for outdoor because the adhesive is destroyed by water. And on the other side, the second disadvantage is that the byproducts of the reaction, of the chemical reaction of water with resin is formaldehyde. So urea formaldehyde adhesive are a continuous source of this dangerous substance. We said that melamine formaldehyde and phenol formaldehyde adhesive can be considered as alternatives to urea formaldehyde adhesives. They are more resistant to hydrolysis, so they can be used also outdoors. This is good. The only great disadvantage is their cost. We said that, for example, melamine formaldehyde raising cost 4 or 5 times more than urea formaldehyde. And we have concluded with some of the properties of the adhesive. I don't want to go in details with such properties. The only one I ask you to remember is the open time. So is the time we have from the application of the adhesive to the union of the elements. So this time is fundamental in every bonding process. Because you must respect this time. You cannot apply the adhesive and wait too much. Otherwise, the adhesive start to set, starts to become solid, and so this prevents the possible good adhesion with the other elements to which it must be coupled. So open time is frequently, I think, the most important parameter, which is the cause of many problems in the furniture sector, especially when the climate change, when for example, from cold period, we arrive to a hot period, maybe like during these days, some days it's cold, some others is hot, and so the open time is strongly dependent on temperature. You can consider that for 10 degrees, for a difference of 10 degrees, the open time can be the double of the half. So if today you are working with, I don't know, 15 degrees, your open time can be, half an hour. Tomorrow, if the temperature becomes 25 degrees, so 10 degrees more, your open time will be exactly the half, so you have only 15 minutes to complete your production. This create, as I said, many problems in the furniture sector because people doesn't know the open time and doesn't follow this simple rule. Normally, when they have some problems, they come to me and they say, "Oh, but we have done always in the same way." Okay, we have done always in the same way, but the temperature of the working place was different. So please take care of the technical data sheets. We have already mentioned the minimum film forming temperatures. We can add also the open time, which is again strongly dependent on the temperature. So there are many information you can get from the technical data sheets that, from my experience, very often is not considered by the user of the adhesive. So this is the last suggestion for you as possible future responsible of the technical department of maybe also furniture company. This is all. It's 5 o'clock. I think we can directly go on with the two presentations. If the students are ready, I don't know who would like to start. You?
I think we can start, maybe. It's okay.
Are you Anna?
Yes, sorry.
Okay. Okay. So I
I share my screen and present it.
yes,
Okay.
your
Yep.
presentation is about deforestation.
Mhm.
Okay. So
Yes.
please start.
Professor, can you hear me clearly?
Yes, yes, very well.
Okay.
Okay, let me just check my screen. Okay. Can you see it?
Yes, but
Yes?
it's not a full screen. Yes,
Yeah, I
yes.
know. Now? Okay.
Now I can see it, yes.
Okay. Perfect. So whenever you want.
Professor, can we start?
Yes, yes, you can start.
Okay, Professor. Thank you. Um, Thank you, Professor, for giving us the opportunity to present our topic. Our topic is about deforestation, and me, Tito Mullah Tanjim Hussein, and Anna Adrover is my partner. We are going to present the whole topic. Next. So this is our presentation overview. First, we will start with a short introduction about deforestation, why it happens. After that, why it happens, what are its effects and consequences, can we stop it, how, and finally the conclusion. Next. So, beginning with a short introduction about deforestation. So by definition, deforestation means reduction of forest area by cutting down trees. And according to World Wildlife Fund, 30% of the Earth area is covered with forest. This area of forest can give us give food, give shelter, give medicine. For about 1 billion of people. And according to Food and Agriculture Organization, the deforestation rate in every 10 years is about 1.3 million per kilometer square. So it's a huge amount of forests are being reduced or cut down. Next. So why it happens? We have found one of the three main reasons behind deforestation. Um, and The reasons behind one of the three main reasons behind deforestations are agriculture, constructions, and urbanization. Next. So I will start with agriculture. So according to Food and Agricultural Organization, 80% of the total deforestation is responsible for agriculture. So in some studies, according to some studies, 33% of this deforestation happens because of subsistence agriculture. What is subsistence agriculture? Subsistence agriculture means when a farmer produce or grow crops for himself or herself and his or her family, and the rest of the percentage is responsible for deforestation is industrial agriculture, which means to grow products or raw materials for industrial production, or for for example, grow oil, rice, wheat, and so on. And the last one is livestock. It means we need space to raise and feed the livestock. Next. The second reason is construction. About 50% of the deforestation is because of construction. So 10% of them are because of infrastructures to meet human lifestyle. For example, to build roads, bridges, airports, railway stations, and so on. And the rest of the percentage is because of infrastructure to move goods, which means we need extraction center, we need industries to move to move. We need roads, we need bridges to move raw materials such as fruits, fresh fruits, fresh vegetables, and also we need extraction centers and also roads, railways to move for example, oil, coal, for example, gas, like that. Next. Uh, the third main reason is urbanization. According to Food and Agriculture Organization, 5% of the total deforestation happens because of urbanization. Now people are moving lots of people are moving towards cities rather than villages or yeah. And if we talk about future, by 2025, 68% of the total population will going to be live in cities. As a result, lots of housing and consumption areas are going to be rising or increasing. Next. So, what are the effects? So it means the main consequences. Next. One of the main consequences is global warming and climate change. So, um, uh, defor deforesting rainforest cause more carbon dioxide emission rather than the cars and trucks are on the world's road. According to world's car-free network, 40% 40% of cars and trucks on the road create the problem of carbon dioxide emission. On the other hand, some analysts believe that more than 50% of the carbon dioxide emission caused by deforestation. If we look at this picture, on the left side, you can see that um, uh, per hectare of area, trees can capture and accumulate almost about 165 tons of carbon dioxide. So on the right side of the picture, you can see according to its age and size, it will capture and accumulate carbon dioxide more or less, and it will increase gradually. But if we cut trees, it means if we deforestate them, then the it will accumulate carbon dioxide. It will release carbon dioxide, which is going to create greenhouse effect, and the world and it will also trigger the global warming and create a climate change. And lastly, deforestation is the most important contributor of climate change. Um, Deforestation is the second largest anthropogenic reason behind carbon dioxide emission after fossil fuel combustion. So from here, my colleague will continue. Thank you so much, Professor, for giving me the opportunity to present my topic.
Thank you, Tito.
Welcome.
So, can you hear me correctly?
Yes, I can hear you. I think Professor also can hear you correctly.
Yes, maybe it is good if Tito will close his microphone because there is a sort of echo.
Ah, yeah, that's what I was hearing. Okay, perfect. So yeah, continuing with the effects and consequences of deforestation, forests play a key role in water flow and water cycle, and actually they act as a natural regulator and filter of water. Trees are used to regulate the level of water between groundwater and environmental water, so rainwater. So if we cut those trees, if we promote deforestation, what we're doing is actually enhancing and increasing the risk of desertations, fires, erosions, and floods, which are not just negatively impact in environment, but only also affecting communities and cities that live around those areas. Following, there's also negative impact in biodiversity. Although forests only represents 30% of the earth, they are home of most 80% of the land-based species. With deforestation, what we're doing is put it in danger their habitat, their home, and with that we are promoting that mostly 4,000 species go extinct each year. We are not only eliminating and losing species, but what we are doing also is isolating them with the geographical deforestation and also changing them because we are making them to adapt to the new the environmental properties and characteristics. So we are forcing them to adapt by our actions and not by natural actions. And last but of course not least, there's a huge effect, negatively impact in people. There's approximately 1 billion people that rely on forests because of housing, food, shelter, income. As you can see here in this graph, these are the number of tree species that provides food to people in those continents. You can see that Europe is not there. But of course, it's a really important issue for the rest of the world, and it's not maybe close to us, but we have to take awareness of the topic. Also, and not in that tragical impact, forests can provide us with medicine and natural properties that we have to conserve and save for this deforestation. Okay, so until now we've talked about what's deforestation, what are the causes, and what are the impacts. But now let's talk about what we can do to stop it, because of course we're still in time to stop it. First of all, it's really, really important to stop illegal logging. What illegal logging is, it's basically the process of obtaining timber illegally, which is basically producing it, transporting, trading with it without taking into account or violating the national and the regional laws. What is illegal logging? It's basically an industry that moves a lot of money and has millions of incomes per year, but it basically puts in danger a lot of conservative forests, and we need to stop it. How we can stop it? So basically by promoting sustainable forestry, which we will talk about later. Also by determining protected areas, but this is an action that mostly governments have to take care of it, and also using new technology. For example, this radar that you see here is made of recycled cell phones and solar panels, and this is a technique which is used in Amazonas, for example, to detect the sound of sawing. When someone is sawing, this device receives a sign and then alters or sends a message to the guards or to the authority which is surveilling the protected area, so they can go to the place where the sawing, with the illegal sawing, is taking place and stop it. And also with technology, we can trace and monitor the evolution of forests to see how, in which parts the deforestation or the harvesting is done. As we've seen, an action to stop illegal logging, it's sustainable forestry, which means basically sustainable forest management. It's used in timber industry at most, and it's basically the process of managing forests in order to meet these three needs, economic, social, and environmental. It's basically producing at a rate in which the industry is satisfied, but it's also respectful with the environment and with the social needs. Of course, it's really important to obtain a certification that ensures that this management is real sustainable and that the wood that we are buying is sustainable. We've seen these two organizations at the beginning of our classes. I'm sure you will recognize them. Also, in line with production, it's really important to consume sustainable commodities. As you can see here in this graph, that represents the number of companies the track number of companies. You can see the number of companies that actually promote or have a commitment with sustainable commodities production and the companies that don't have. The one with higher impact is cattle, but we don't have to lose track of the effect of timber and pulp industry. And how we can stop this, or how can we promote the sustainable production using also technology to monitor the areas in order to promote sustainable purchasing. And also we as customers have the opportunity to modify our tendency and buy only, in this case, for example, certified wood or goods that we know that have been produced sustainably. And finally, now we've seen like the prevention activities that we can do. Now, when the damage is already done, what we can do to make it less harmful is reforestation plan. It's based on the 4 R's: rehabilitation, reclamation, reconstructions, and replacement, which basically what they look for is to recover the plants and the species and the environment that was deconstructed and replace it, and also rebuild it. So how can we do it? With these 4 R's and also with planting new trees. I'm sure all of you know the United Nations initiative of 3 million trees, that it wants to meet the plantation of 3 trillion trees until 2030. And finally, the conclusion we've reached doing this project, this presentation, it's basically that deforestation, it's mostly due to human actions, and it's then in our power to stop it and to repair it by consuming and producing goods, in this case timber, for example, in a regulated and supervised way, and that it is basically in our hands. And that's all. If someone has any question, feel free to ask. Thank you for the attention.
Thank you to you. Very, very interesting presentation. Thank you, Tito, and thank you, Anna. Are there questions from the other students? No, at the moment. No, it's only two comments from my side. The numbers, some of the numbers you presented are really impressive. For example, the number of species that disappear every year is dramatic.
Yes.
It's unbelievable. This is one of the comment, and the second is I think that also education can be a good instrument to use. What do you think? Because sustainability is the right word, but also maybe it must be related with the education of the people. If they understand that sustainability is something that will also produce a good economic impact for the future. It's just a comment, but what is your idea on this?
I think that definitely, as well as in other areas, sustainability, like education, is really important for young generations and also for the ones that are now, because yeah, the young generation of the future, but the ones that have to take right now actions are also the adults, let's say it this way. So it's really important to settle this base and to be sure that everybody is conscious and really knows what the meaning of sustainable and what the consequences of sustainability or not sustainability can be.
Yeah, yeah. Because sustainability does not mean only to be green.
Yeah.
It means also to create a possible development, economical development, also for the. So this is something I think that not many people really understand when we speak about sustainability. They think, okay, the environment, green, no chemistry, and so on. But sustainability, it's something more. It's related with economic purposes. Yeah. Okay. That was.
Actually, as a fact, I saw that, for example, with a legal login,
Yeah.
like with sustainable login, let's say it that way, it's possible to make more money than with a legal with a legal login. So it's
You're right. Yeah. Yeah.
it's also this wrong concept that making things illegal is more profitable than making things legal. So that has to change as well.
Professor, I want to share some of my experiences from my country. In my country, there is no like from the wood industry, like from the furniture industry. They don't have any kind of until now. They don't have any kind of planning about sustainability in my country. So yeah, and as a student, when I was in school or college, I also don't know much about sustainability. But when I was doing my study, then I came to know this kind of word and this kind of psychology or this kind of thinking. So
Yeah.
yes.
Yes, it's a kind of thinking, as you said. It's right, and again, not only related with okay with a flag, but it's something more. It's something that can be deeply present inside our brain and our soul, I think.
Yes.
Okay. So thank you for your
You're
good
welcome.
presentation into the presentation. If there are no questions from the other students, we can move on to the second presentation.
Thank you, Professor.
Thank you to you again. The second presentation is from Vanda and Ashraf.
Yes, sir.
Sorry if I didn't pronounce your name correctly.
It's fine,
Yes,
sir.
it's okay.
Okay. And so please, your presentation is about wood and plastic composites. That during the course I simply mentioned, but it's good that you can say something more. Thank you.
Okay, sir. So, sir, can you see my desktop screen?
Yeah.
Okay. Okay. Hi, Professor, and all of the fellows. The topic we are presenting today is a wood plastic composite. And we are two group members. My name is Muhammad Usman Ashraf, and I've done electrical engineering in bachelor's, and I've got some work experience as a maintenance engineer in the refrigeration industry. And other group member is Wanda. Agenda for today's presentation is, first of all, we will have introduction of wood plastic composites. Then we will go for historic development. And after that, we will go briefly for processing and testing of WPCs and properties following applications, advantages and disadvantages. And after that, we will conclude the presentation. So when we start for introduction of wood plastic composite, as the name suggests, it's wood fiber and combined with thermoplastics. It's basically a part of normal fiber plastic composites. And here wood fiber or wood floor can be mixed with thermoplastics, as they are the part of bigger normal fiber composites. So they may contain other no cellulose based fiber fillers. For example, shelled nut bodies, mesh filaments, as most of the material which is used here is recycled. So we can use several types of wood for this. So next, we have first generation WPCs and new generation WPCs. We categorize it into two parts. Like for first generation, we go from 1960 to 1990, before the introduction of extrusion machines in this industry. So for first generation WPCs, they were recycled wood chips, floor and binder, and they were not designed specifically for some applications, so they were for undemanding applications. So about a new generation, it's high performance products, as the extrusion machines are used, so we can make a different shape and sizes as per the manufacturer or customer demands. They have got a good mechanical properties, and they are high performance products. Now we come to historical development of WPCs. If we look into the history of wood plastic composites, it was first introduced in 1960. A company, it was based in Milan, Italy. It was Coverna. They first introduced plastic wood, and following in 1975, GOR Italy, the company's name, they were in 1975, they were wood stock patents. Following in 1983, American Woodstock Lear Corporation, they basically created thermoforming sheets for auto interiors, including 50% of wood floor and 50% of polypropylene plastics. After that, in 1990, there were Strandix Corporation. They first introduced extrusion profiles and shapes in this industry. In 1993, there were Anderson Corporation, and they used WPCs for French doors and window lines. Now, as we come on exponential growth of the production, from in 1995, its production was just 50,000 tons. And if we compare it in 2015, it's just for US, it raises to 1.3 million. And there is a company, Xeon Market Research. Their analyst claims that or the global market of WPCs in 2016, it was 4.37 billion, sorry, and it is expected to raise up to 8.76 billion in 2022. And now if we look into the other table, it's between 2010 to 2015. We can see that the biggest global share in 2015 of usage of WPC is 48% for North America, and following is the China, which is using around 33% of WPCs. And if we look for Europe, they are using around 9% of the global share. It's the report of 2015. So in the other pie chart, if we look at this market share by application, we can see that around 65 to 70% of WPCs are used for building and construction, and around 15% is used for automotive components like the interior of our automobiles, and around 10% is used for industrial and other consumer goods, and the 5% is used for other tasks. Now, we will discuss briefly the production process of WPCs. As, as we can look into this diagram, we will go with a step by step. First of all, there is a recyclable machine that is for the collection of waste polypropyl, propylene and polyethylene, which is the polymer of ethylene. Here, what we do, these plastics are crushed into plastic flakes. Then following is the wood milling machine. It converts the waste wood into wood floor or wood fibers. Then there comes a wood powder dryer. That is, this dryer is used if there is any sort of moisture content in it so that it can be removed. After that, the recycled plastic, wood powder, and few additives or binders and other related chemicals, they are mixed together in a wood plastic a composite mixer. Here they are mixed together. After that, there comes the department of granulating. So here is a granulating machine. It creates the WPC's granules in a perfect composition. And after that, there comes extrusion line. In extrusion line, finally, the product is converted into WPCs. Manufacturers, they can choose any type of mold as per their requirement, so that they can create it of different sizes or different shape as per the area or the customer of that country or area demands. After that, there comes embossing machine, a brushing machine, and sanding machine. These are the machine, they are used to give it a little bit look to the body or the cutting like the wood. So other are, you can see the WPC products examples there, and the applications later will be given detail will be given by my other colleague. Then there comes a testing of WPCs. After our product is prepared, they go through several tests to check its durability and other factors. First of all is moisture sorption test. This test is basically used to get to know about its ability to resist to the moisture. In this test, what happens that first of all, we weight the product. After noting down its weight, it's dried at 100-degree temperature. After that, in distilled water, it is soaked for some time, and then after that, it is again weighted. So that from the difference in weights, we can get to know about that how much does this material have soaked the water. After that, there comes weathering test. In weathering test, we just see the ability of the material, that how it reacts to climate changes, like when it is exposed to UV radiations or other climate change, like or other moisture, how it reacts. For this process, it follows 3-4 steps. First of all, the material is introduced to UV radiation at around 60-degree temperature. In second step, the material is condensed at 50-degree temperature for around 4 hours. After that, for a further 4 hours, the material is soaked in water. After that, in the fourth step, it's dried. So after drying, it's seen that we are able to see how it has affect its surface and other related activities which needs to be monitored. The third test is biological decay test. This test is basically performed to see how this material reacts to the action of fungi or the other microorganisms. So when they are introduced to it, how much of its mass is reduced. So for this process, basically the experts, they choose 3 different types of soils. And for the first type of soil, it can be clear without any kind of a microorganism or fungi. And the other two types of soils, they can have like the normal forest soils, which have some a percentage uh, of the fungi or bacteria in that. So that after doing this test, they can get to know that how much the mass have been decayed by this test. And remaining or compression, tensile, and bending test, they are mainly used to check the compression, tensile, or bending resistance, or the modulus of elasticity of the material, so that they can check it further. So that's all from my side. So my other user partner, he can continue now.
Okay, thank you.
Thank you.
Thank you, Usman.
Thank you.
Are you seeing the presentation then?
Yes.
Okay. So, talking about the properties, we can say that wood, uh, the wood plastic composites are composite materials and have properties both of materials of plastic and the wood. They have stiffness and strength between those for plastic or wood, but the density is generally higher than either. Moisture can only be absorbed into the exposed section of the wood and is not transmitted across the plastic boundaries. The properties of WPCs can be tailored to meet the product requirement by varying the type of wood or the type of plastic. We can see that they are resistant to biological attack due to the fact that the the wood is coated by the plastic, mostly coated by the plastic. Then if we go to the applications of the WPCs, we can see that according to their properties, the WPCs can be used for indoor and outdoor purposes. And current applications are largely in finished products such as decking, cladding, and window frames, or the kitchen cabinet for the indoors purposes, or office furniture. And we can see that going to the advantages and disadvantages, we can see that the WPCs are hybrid material, combining the best properties of both wood and plastics, and they use low cost and plentiful raw materials, and wool waste and recycled plastic becomes asset instead of liabilities. And then they are competitively low priced and are competitive with traditional materials such as timber, MDF, and PVC-U. And they are easily produced and easily fabricated using traditional wood processing techniques. And they are available in broad range of finishes and appearance. And and then they are easily recycled after use. The disadvantages are that the initial moisture content is very low and the rate of absorption is very slow. However, the moisture in the composite is not uniformly distributed through the cross section, and the outermost part or surface of WPCs can reach a very high moisture level, which is high enough to support fungal degradation. In addition of that, a moist environment will cause the wood particles close to the surface swelling and shrinking up in the time, and this will cause stress within the material and create micro cracks inside the WPC material. Then we have that the degradation by fungi and other microorganisms may occur, and in that case there is a mass loss in the WPCs, which will make the material become weak and not able to support hard load again. And then we have that the WPCs has lower strength and stiffness than wood, and it can be reduced further in case of degradation. It may not be suitable for use in those places that have large seasonal changes in atmospheric moisture because of high dimensional changes of wood. In conclusion of that, we can say that because wood plastic composite is created from a system that starts as a paste, it can be molded to almost any shape and size, including arch and bend shapes, which are difficult to be reached with certain stiff materials. Then, sorry, the flexibility extends to color as well. WPCs can be dyed or colored to suit almost any design and scheme. From a functional standpoint of view, wood plastic composite is moisture resistant and rot resistant, meaning that it will last aesthetically and integrally longer than normal wood. And WPC is more heat resistant than typical lumber, creating a product that can be used in locations where normal lumber may bend or warp. We can also say that the future of wood plastic composite will ultimately depend on many factors as the new product identification, the product quality improvement, and the consumer perception of the WPCs and performance of the WPCs. Um, that's all. Thank you for the attention. If there is any question, we are here.
Thank you for your presentation. Are there questions from the students? Not at the moment. Just one comment. It's again something related with sustainability, because it's the result of putting together two recycled materials, as you said, wood dust and recycled plastic. So it's again something that can be considered in the field of sustainability, as we mentioned before. Now, I have one curiosity. I don't know if you have the answer, because especially Ashraf presented some tests.
Yes.
Yes. And then you know that I work in a testing institute, so it's my field.
Yes.
I've never found references, reference values for the test that you mentioned, because they are you can do the test. You have the result, which is knowledge about the material. But on my knowledge, there is no a limit value, a reference value to say the product is good or not. It is right? Did you find something more than
so basically, I was following 2 or 3 research papers, and you are right that I didn't find any exact value, but they had mentioned the standardized methods that can be used for these processes. And if you want, I can share the links of the research papers and the other references with you as well.
Okay, thank you very much.
Thank you, sir. Thank you.
It's not mandatory, but if the presentation if you would like to share with me, I would be happy.
Thank you, sir.
Okay.
Thank you very much.
Because I like them, I collect them, and
Sure.
during my holidays, I go there and see again your presentation, and
Okay, sir.
but
We will mail it to you.
it's a good source of knowledge also for me.
Sure,
So
sir. Sure, sir. I will do that in some time, sir.
thank you. And the same for the other student. It's not mandatory because it's your work.
Yes.
But if you would like to share with me, I would be really happy.
That's
Okay, sir.
Are there any questions from the other students? No. Okay, you mentioned that the cost is one of the fundamental benefits of such materials. And it seems also that the use is increasing. Is it right that the using of UPC is increasing all over the world?
Sir, if we just consider Europe regarding this matter, in Europe, only Germany. In Germany, it's increasing. On the other hand, not most of the countries in Europe they are working on it. But if we, as I shown in other graph, if we compare like in US and like in China, if you see in Russia, it has I will just per annum. I can see here that in Russia, per annum, there is a growth of 48%.
Oh, it's a lot.
Yes. Yes, from 2010 to 2015, there was growth of 48%. From 10,000 to 70,000, it has increased. So we think that, and we had shared the table chart as well. So we are hopeful that within the coming time, its usage is increasing globally.
Okay. So if there are no other questions, I think we can thank you again and close also this second session for the student presentation. It's I think all for today. It's 10 minutes to 6, so we can close here the lecture and see again on Friday. Friday we will start this last new subject dedicated to coating materials, but I think I have to reduce it because there are many presentations for the following lectures, and so I will try to reduce to the possible important information and avoiding to about such materials. Okay, let's see what I can do on Friday. Okay, it's all for today. Thank you again for the students for their presentations. Interesting, all of them. And see you again.
Thank you very much.
Okay.
Thank you.
I remain
Bye,
here
sir.
for
you.
5-10 minutes.
Goodbye.
So if there are any question, any curiosity, I'm here on my desk for the following 10 minutes. Okay, bye bye.
Bye.
Thank
Thanks.
you very much, sir. Bye.
Thank you.
Bye.
Thank you, sir.
Excuse me, Professor.
Okay, I'm here.
Professor, my group want to present on 12th instead of 14th because we have another presentation on 14th. So if it is possible, we want to present earlier.
So which is your presentation is? I can
Wood recycling processes, Armagan roof. and Ujjwal Bhandari.
Okay, sorry.
Yeah, wood recycling.
Is this one? So you want to present it
On 12th
12.
of May.
Okay. The 12 is okay. Next Wednesday. So next Wednesday, I think we will not have any a lecture for me, but only presentations because there are 5. Okay, no problem for me. It's right.
Okay.
Okay.
Thank you, Professor.
You're right.
Bye.
Okay. Bye bye.